After starting up a GC, it's a good idea to run a program temperature cycle and just look at the baseline. What this does is enable the operator to see that the system is reasonably clean and free of spurious hydrocarbons in the system. And to run the system, we just simply need to push the start button. Notice that everything is in the green. It says it's ready. It says the internet's okay. And to start the GC, we simply push the start button. And what it's doing is allowing the electronic pressure controller to stabilize. It takes about 5 seconds. And as soon as that's finished, what you see over here on the screen is the chromatogram progressing. And this method is set up for something we call column resolution check mix. It's a standard that is sold by ResTech. It's C10 to C20, and it's C6 to C20. There are some very nice isomers around the C10 region that, if you get nice baseline or near baseline resolution, indicates that the column is healthy, and that's why it's called column resolution check mix. And you can see as the analysis progresses here, the flame ionization detector is sensing something. Could be a little bit of septum bleed that's getting through after the septum purge. If we blow up the screen a little bit, we can see what the noise levels look like. And the apparently digital steps on here are fundamentally at the point of where the digitization of the signal is occurring. You can see there's a little bit of wiggle in the baseline from drift and detector noise. These are at very low levels. These are 1,000 microvolts here. This one right here is some kind of hydrocarbon materials that are in the system, but again, it's at very, very low levels. When we need to do low-level measurements, probably the best thing to do would be to run half a dozen cycles and let everything get just as clean as it can be inside. But these components are essentially any hydrocarbons that are left in the system after having started up a cold GC that's been shipped by UPS across the country, and it will stabilize after a number of runs. Let's just go back and have a look at what it looks like at the scale with which we're going to run samples. And you can see it's pretty low level noise and components that are in the system. Okay, we've run a blank and we had a clean baseline there, and it's time to run some samples now. Here we have a small vial of low concentration column resolution check mix. Again, it's about a C5 to C20 sample, and we're going to inject a half a microliter of the standard into the GC. And with an automated valve, this procedure is not really relevant because the automation takes care of the countdown. But on manual injections, basically what we're going to do is push the start button, and we're going to watch the counter count down from 5 seconds. This is letting the electronic pressure controller stabilize so we get the right split flow rate and in fact the right amount of sample into the column. So I'm going to go ahead and push the start button. And you can see the timer is counting down, and the technique is to inject at 0. The chromatogram is going to show on the screen here. This is the hexane solvent peak along with some methylene chloride. There's going to be 4 components show up about here. That's C10. The resolution of these C10 isomers here is the important part of resolution check mix. You can see on the x-axis here that we have a time scale of seconds, and this is about 35 seconds for those 4 components to come out. The total analysis program temperature cycle is 140 seconds. We will finish with C20 out here in about 90 or 100 seconds, somewhere in there. And we just allow the program temperature to continue and make sure that we clear out the column for any other components that might be present over the C20 targeted analyte there. And you can see the chromatogram progressing nicely. Signal to noise ratio is excellent. This is about a half a microliter of 1,000 micrograms per microliter of the CRM check mix. And there's C20, and we're essentially finished with the chromatography at that point.